I guess this is going to be part 2 of page 34. I don't know exactly where it cut off, but it cut off and stopped recording again. We're modeling, trying to find 5/6 of 2/3. I drew my model right here and I cut it into 3 pieces and I shaded 2 of the 3 in blue. Then vertically, I cut it in 6 pieces and I shaded 5 of the 6. Where the green developed, where because of the blue and the yellow overlapping, it gave me 10 pieces of 18, and I simplified it down to 5/9 using the greatest common factor. And when I say using the greatest common factor, I mean using the greatest common factor between the numerator and the denominator of 10 and 18. And the greatest common factor there would be 2. So whenever I divide the 10 by the 2, I get the 5. And when I divide the 18 by the 2, that's where I got the 9. Then I went down here to the equation format, and I used the same exact problem. And we were talking about using the greatest common factor to simplify the problem before I got to my final solution. Now, there's times that you really want to do this. Now, when you're dealing with itty bitty numbers, it doesn't really matter. You can go to this format and then use the greatest common factor to simplify afterwards. But there's going to come a time when you have numbers that are really big within your problem. If you make those numbers smaller first, then it becomes so much easier to evaluate the final solution and see, does it need to be simplified some more? And you're dealing with smaller numbers. Dealing with smaller numbers, you're less apt to make more mistakes. So this is an example of using the greatest common factor to simplify the problem itself. So if I take 5/6 of 2/3, what I'm doing is I'm looking at the problem itself and I say, is there a numerator and a denominator? Crisscross, like 2 and 6 or 3 and 5. There is nothing in common between 3 and 5. 3 and 5 are both prime numbers, and the only factor that they share is 1. But 2 and 6, however, they're composite. Well, one's a prime number and the other one's a composite number, but they share the greatest common factor of 2. So if I take that greatest common factor that I would normally do at the end and I multiply or divide it here before I multiply my problem, that will help me reduce my problem. So now my problem is going to be 5. I didn't do anything to it. And then 2 divided by 2 becomes a 1. And then 6 divided by a 2 becomes a 3. And I didn't do anything to this. And look what happens. I get my problem solution in simplest form without having to evaluate it at the end. So it made the problem smaller before I got to the final solution. So they give you a check in the book. And so let's do that. They want you to find 3/4 of 4/9. I'm going to use the equation format. Then I'm going to look for the greatest common factor between any numbers, if there's any kind of relationships, and we've got all kinds of relationships going on here. 4 and 4, they have a relationship. Their greatest common factor would be 4. So I'm going to divide both of those by 4. 3 and 9 also have a relationship. The greatest common factor between 3 and 9 would be 3. So I'm going to divide both of those by 3 before I get to the end. So I'm going to simplify my problem using the greatest common factor with a numerator and a denominator before I get to the final problem. So I'm going to rewrite this. And I know that I have multiplication going on in top and bottom. 3 divided by 3 makes that a 1. 4 divided by 4 makes that a 1. 4 divided by 4 is a 1, and 9 divided by a 3 is a 3. Look how easy that problem just became. 1 times 1 is 1, and 1 times 3 is 3. 1/3 would be my final answer. So now we're going to move on to page 35. This should be the last page of instruction for today. This example wants you to learn how to multiply fractions by whole numbers, which you can't do. You've got to put your whole number in a fraction format. Okay, so I'm going to do both modeling and equation using the same problem. I'm finding 3/4 of 3. The very first thing I want to do is draw a model that represents 3 wholes. Yep, that's just perfect. That represents my whole number 3. Now I need to take those and I need to cut them up into pieces of 4, each one as pieces of 4, because the denominator here is 4. Then I need to shade 3 of the 4 in each of the pieces. And I'm just going to use blue on this one because there's no point when you're talking about whole pieces, there's no point in doing a second color because this will give you what you need. And so that represents 3/4. So now I'm going to count how many pieces I have out of the 4. 1, 2, 3. You know what? I can just number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 pieces of 4. I have to simplify that. Now, you can do this 2 ways. You can either do it visually, and I'll show you that in a second, or you can just do long division, and I'll show you that in a second too. But you're going to ask yourself, if it takes 4 pieces to make a whole and I have 9 pieces, how many holes can I make? Well, you start skip counting by 4s until you get close to how many you have in your numerator. And I know that I'll have 2 sets because 4 and then 8 gets me really close to 9. And I will have 1 piece left over when it takes 4 pieces to make a whole. Now, you can do this visually. Let me show you. You have to imagine that those are a representation of 9/4. I did not change the value. I just changed the way I represented it. Then you circle groups of 4. You were able to circle 2 complete groups with 1 piece left over. when it takes 4 to make a whole. So you could get it that way. Or you can do long division. The numerator is always divided by the denominator. And then you just write your remainder as a fraction. Write your remainder as a fraction. Okay, so now I'm going to do the equation way. Using the same problem. Three-fourths of 3. Notice that I represented this differently. Here's the reason why. You have to write a whole number in fraction form. You can't multiply a fraction by a whole number. You have to represent this whole number as a fraction. So whole numbers must be rewritten by fractions. Here's the easy part. You just slip it over top of 1. That's all you do. You put a 1 underneath. And here's the reason why. Your denominator is 1 because if you only need 1 piece to make a whole and you have 3 of them, then how many wholes do you have? You still have 3 wholes. You haven't changed the value of it. You've just represented it differently and rewritten it differently. So once again, we look for cross reduction using greatest common factor. I don't have any right now, so this is 3 times 3, which is 9. And then 4 times 1, which is 4. And once again, we have 9 pieces. When it takes 4 pieces to make a whole, how many wholes can we make? 2 wholes with 1 piece left over when it takes 4 pieces to make a whole. And that's our final answer. Simplified final answer. And now you know why we did so much practice on simplifying improper fractions to mixed numbers and then mixed numbers back into improper fractions. We'll get to that part of it while we practice that in just a little bit. But that's why I wanted to kind of preload that information about simplifying improper fractions to mixed numbers, because now we need it. Here's a check. It's also found on page 35. The check wants you to find 3/5 of 4. So we're going to use the equation method. Remember your whole number, simply place it over 1. Look for cross reduction. There is no cross reduction available. So 3 times 4 would be 12. And 5 times 1 would be 5. So we need to simplify this improper fraction to a mixed number. And I'm going to do long division this time. And I'm going to write my remainder as a fraction. This is always your denominator. Your divisor is always your denominator. And your final answer is 2 wholes and 2 pieces left over when it takes 5 pieces to make a whole. So 2 2/5 is your final answer. Now you're going to have some homework practice on just multiplying fractions by fractions and fractions by whole numbers. Please be sure to look to see if you can cross reduce before using the greatest common factor before you come up with your final answer. It makes it so much easier instead of dealing with such big numbers. It really cuts everything down to size. Thank you for watching.